All right. Good morning, boys and girls. We're going to be working on writing equations today. So on the top of your notes page, you want to write that title, Writing Equations. This is going to go into page 86 in your journal, as 85 was where you're writing your objective and your title. All right, so what we're going to do today is a continuation of something you've done in 5th grade and a combination of things we've already learned this year. So what we're going to do is we're going to use tables and graphs to find the relationship between x and y. It's not always called x and y, okay, but x and y are basically the independent and dependent variables. Variables are represented by a letter, if you remember. So let's get started. I'm going to start with the bottom of your notes page right now, and we're going to talk about this real life problem right here. Okay, this problem says James buys oranges by the crate. He uses a table to compare the number of oranges he has to the number of crates he buys. So basically, if you read your table, the number of crates is represented by C. If he buys 1 crate, he gets 13 oranges. If he buys 2 crates, he gets 26 oranges, and so on down the line. So what we have to do is find which equation represents the relationship between 0 or O for orange and C for crates. We're going to take this multiple choice right here and ignore it for just a minute, and we're just going to look at our table. Okay? What we have to do is we have to find the relationship between 1 and 13. Okay? We could get from 1 to 13 in 2 ways. We could add 12, right? 1 plus 12 equals 13, or we could multiply by what? What times 1 would give you 13? 13. So there are 2 ways. So by only looking at one example, we can't determine whether this is an additive pattern or a multiplicative pattern, whether we have to add to x or multiply something by x. So the first thing I want you to do is I want you to put your x up here and your y here to remember that x is your independent variable and y is your dependent. What in the world do I mean by independent and dependent variables? Well, if you notice, he's buying crates of oranges, okay, and the number of oranges he gets depends on how many crates he buys. So you're independent. He can buy as many as he wants, but that's going to determine how many oranges he gets. So this y is always going to depend on what x is. And one way to remember this is x has 2 legs, so it can stand on its own. It's independent. Y only has 1 leg. If it stands on its own, it's going to fall. So it has to depend on something else to hold it up. Okay? So you're dependent. Y depends on x, whose feet are on the ground. All right. So what we have to do here, we determine 2 ways to get from 1 to 13, but we have to now take it to another one of these and see if that works. Well, does plus 12 work here? Is 2 plus 12 26? No. So let's go ahead and try the times 13. Is 2 times 13 26? Yes. So that works. So if it works on 2 of your 2 rows of the table, then it will work on the rest. You can check one more to be absolutely sure. 3 times 13 is exactly 39. So our pattern here is we multiply x times 13 to get y. So what we're going to do is we're going to take that information and now we're going to write an equation that starts with y. Y equals what? X times 13, right? Or we can say y equals 13x. So now we can come over here, now that we've, but we didn't use x and y, we used c, so my x is going to be my c, and my y is going to be my o. So the number of oranges, we're going to find the number of oranges by multiplying the number of crates times 13. So O equals C times 13 or 13C. Okay, and that tells us that this is the correct answer. The number of oranges depends on how many crates he buys. But see this one right here? It gives you the same formula, but it reverses your oranges and crates. So that's only there to trick you. Okay? So the number of crates doesn't depend on how many oranges. The number of oranges depends on how many crates. It's not an additive pattern, so that can't be right. It's not an additive pattern, so that can't be right. That's basically all there is to it, to take the information you're given and turn it into an equation. Y equals something, okay, or whatever letter they give you. So let's go ahead back up to the top, okay, and let's look at number 1. All right, we have 2 is my x and y is my 9. Again, my independent is my x, my dependent is my y. My y is going to depend on what my x is. So how do I get, the question I have to ask is, how do I get from 2 to 9? Well, there's no clear multiplicative pattern there, but I do have an additive pattern. I can add 7 to get 9. Okay, let's see if that works. If I add 7 to 3, do I get 10? Yes. If I add 7 to 4, do I get 11? Yes. So this pattern is x plus 7 equals y. So I'm going to start with my y. Y equals x plus 7. That's all there is to it. Okay. All right. Now, this was a horizontal table. Remember, horizontal is laying flat. This is a vertical table. No different. What is the pattern? How do I get from 2 to 8? I can add 6. Or I can multiply by what? 2 times what equals 8? Times 4. Well, if I add 6, does plus 6 work here? No. So plus 6 is not correct. Let me try times 4. Times 4. 2 times 4 is 8. 4 times 4 equals 16. 6 times 4 equals 24. So my pattern is times 4. And now I have to write it starting with my y. Y equals x times, we're not going to put it like that because it's going to be confusing xx. So 4 times x would be written x times 4, or y equals 4x. Remember, 4x means 4 times x. All right, number 3. Now you notice we don't have tables anymore. We have a graph. But all we're going to do is make a graph, make a table from the graph. So I'm going to put my x first, and then my y, my dependent, 2 legs, and my independent, 1 leg. And I'm going to just list my x values. So look at the first point. What's my x value here? It's 1. What's my x value here? It's 3. What's my x value here? It's 4. All right, and then I'm going to come across and I'm going to find my y values. What goes with 1? 7. What goes with 3 is 9. What goes with 4 is 10. So is this an additive? Am I going to add something to x to get y, or am I going to multiply? Well, let's see. 1, let's start with the additive. Plus 6 is 7. Plus 6, 3 plus 6 is 9, 4 plus 6 is 10. So my equation would be what? Y equals x, what's my pattern? Plus 6. And that was very simple. I took my x values, I took my y values.
Good morning, everyone. Today is...
Okay, so the very last one we have, sorry we were interrupted by announcements, is another graph. Once again, you make your table from the graph. Your x and y, your independent and dependent variables. Y is going to depend on x. So if you notice, we have 1 and x values are 1, 2, and 3. I can list all my x values, and then the y values that go with them are 3 goes with 1, 2 goes with 6, 3 goes with 9. Now over here we had an additive relationship because we had to add to x to get to y. Look at this one. If we use plus 2 to get from 1 to 3, plus 2 does not work for 2 to 6. We cannot say 2 plus 2 equals 6. So it is not additive. I'm going to try multiplicative. What would I multiply 1 times to get 3? I would multiply it times 3. Does it work here? Is 2 times 3 equal to 6? Yes. Is 3 times 3 equal to 9? Yes. Now how do we write that as an equation? We start with what? Y equals, and we have 3 times x, or x times 3. You might see it either way. You might see it as x times 3, or you might see it as 3x. 3x means 3 times x. So you might see it either way. All right, and that's all there is. We're going to do some independent practice, and make sure you have taken all the notes and you have everything written down and you understand it. Ask questions on Zoom if you do not understand it.